So here you see with an ERP solution, you have accounting software modules, financial modules, manufacturing modules, and you can pull these in as you need them. So as particular areas of the organization become more connected and you want to be able to extend them, remember we talked about the value system, value chain within an organization. If you want a seamless integration of information from one point to the next within an organization, then ERP solutions allow that to happen, as each of these modules can talk to each other. So, for example, the way this looks here, maybe the accounting and manufacturing will be able to exchange information between those modules to allow for some kind of predictive capabilities. Maybe with your sales and manufacturing, for example, your sales would be able to understand the manufacturing process, the times that it takes to manufacture a product, and sales could then forecast when those products would be available and even when there would be a high inventory of them. And particularly if there is a high inventory, do some different type of marketing or price structure for them. And you notice with this grid that you also have a couple of modules that are being replaced with HR and data analytics. Maybe they aren't going to be used by one particular vendor, but either replaced by an in-house solution, or as is shown with data analytics, a different ERP vendor has a module that could be put in here. And this seamless integration across vendors is also an important part of an ERP solution. It's not always the case, but it would be an important part if you want to have a solid ERP infrastructure. Now, all of this also shows you this middle bar here. It says information and hardware infrastructure hiding. The idea here is that for your users and customers, that you don't want them having to think about where the data exists, how it's been offered. What the technology platform behind offering these modules is just needs to be available, whether it be in a client-server type of infrastructure typology or maybe some kind of cloud typology. So when we talk about computer networks, the IT infrastructure component, there are a few different types of opportunities or offerings here. You have one which is called the distributed type of environment, where you basically have the IT that exists in small pockets in different areas. So there's a picture, figure 7.4 in your book on page 213, which shows a New York office, a Denver office, and a Dallas office. Each of them are replicating their services through a server and a client. And then the services communicate to exchange information and even maybe perhaps mirror themselves. So it's not a very efficient infrastructure, but it is effective when used for quite some time. Client server is again another infrastructure that's been around for quite some time as well. Basically, that means you have a server or set of servers that are offering different types of services. For example, you could have a database server, web server, an application server as it shows in figure 7.5, and the servers then connect to a central data point, data repository, and then those services offer out to their clients the services that those clients are requesting. These are some of the graphics. This is the one which we just referred to. The third one that the book mentions is the tiered infrastructure. For example, here it looks like this. So if you have a one-tier infrastructure, what that really means is you have a single machine and all the services and data exist on that single box. And when PC power was becoming more affordable, we saw companies move away from the mainframe and terminals to these workstations at the time, where a lot of the data was maintained locally on those single devices. We never really got away from the two-tier architecture where you had a web server of some type. And this is showing a web server example here. And then web client would interface with that server, requesting services from it. Now that could be a database server or some other type of client running a client software application on it that interfaces with the database server. Then with the three-tier architecture you see here, we also can add a third tier where there's a database perhaps that's feeding data to the web server, which is then hosting it out to the web client. And then with the N tier, when we add that business logic here, now we are adding different types of services such as application services or application servers, which give a specific type of capability that allows us to then extend that, become a little bit more scalable with our infrastructure than we would in the one-tier, two-tier, or three-tier architecture. And that leads us then to where we are now with the cloud. As it says here, the hottest technology trends today is creating these clouds. And this is about as ubiquitous as it comes for your customers or your end users, in that everything occurs away from the infrastructure that they would typically see. It's mostly web-based, and what you're doing with the cloud is providing as many services or resources as you would like from those either public or private clouds. So for example, if you're doing everything internally that you would want in terms of web hosting and data storage and so forth, but you wanted to provide some kind of application software not in-house but out of a public cloud service, such as the Amazon offers a bunch of different services, then you would be able to provide those services from Amazon from their cloud and do everything else you have been doing internally. And you can push as many things out to the cloud as your organization feels comfortable doing. One of the things about cloud services is that as much as you put out there, the cloud is quote-unquote owning it. They are hosting it, they're holding it, and the service level agreement you work out with the cloud provider will dictate exactly the arrangement, of course, as far as how they're hosting those applications or the services or holding your data for you. But you have to keep in mind, if you're putting information in the cloud provider is actually maintaining that information for you. Then you see these other facilities here. There's data storage, backup facilities, development tools, basically anything you want to do. This is what's just showing you the cloud. There's a picture of the cloud. This means that some organization with a whole bunch of infrastructure providing these services out through either a private or public internet. Some of the goals on why companies are interested in using the cloud services is that it's cheaper, certainly more efficient to use than developing and building and hosting your own services, because you're basically using shared resources that other organizations are also using if it's a public cloud anyway. So you can pay for what you need when you need it. It's not up to you to be able to scale up your infrastructure or growth or scale it down if you're too large. You can ask your provider to do that for you. Then you can align your computing cost with the level of business activity. This goes with what they're saying in the first two bullets. And of course, all of this reduces your cost because since it's a shared service, the hosting company such as Amazon doesn't feel like they have to recoup all their costs from one customer. They can distribute that process over customers.